Indicators in acid-base solution. Indicators, we use them in the titration, and they are basically weak acids, and which show one color when they are in the protonated form and another color when they are in unprotonated form. So for example, let's say this is an acid, weak acid. That is an equilibrium reaction. So here if you add the indicator in this weak acid solution, it will show one color in the acidic medium but another color in the basic medium. So what it means is, if the solution is acidic, it's going to show, for let's take an example of this indicator, phenolphthalein. Phenolphthalein is colorless in the acidic medium, but it shows pink color when the solution is basic. So that means if you're doing a titration, let's say you have acid here and you put 1 or 2 drops of the indicator and you're adding sodium hydroxide, a base, to neutralize this acid. So as long as this is acid, it will be colorless. So 1 drop will make the solution basic, and then the color will change to pink. Now, if the ratio of conjugate base over acid is less than 10, then color 1 dominates, means you have not equal, means you have more acid, you have slightly more acid than the base. But if the ratio of concentration of conjugate base over acid is greater than 10, means you have more conjugate base, then color 2 predominates. And if the ratio of this is equal to 1, then the color change occurs near the pK of the solution. Very important point. So you need to understand the difference between the endpoint and the equivalence point. The equivalence point of a titration is where all the acid get neutralized by the base. And that doesn't mean you're going to see a change in color there, because solution is kind of neutral. Endpoint is where you see the color change. And when you're reaching the equivalence point, the pH changes very rapidly. So look at this diagram 17 point. The equivalence points of many weak acid, strong base titrations. This is or in the pH range of phenolphthalein color change, which is 8.2 to 10. But here, first thing, um, 17.13. This is an example of the titration of the strong acid and the strong base. And what they are doing is they are using phenolphthalein as an indicator. Phenolphthalein shows the color change in the pH range of 8.2 to 10. So we can use this indicator for strong acids with strong bases titrations. We can also use this indicator for weak acid strong base titration. And what's the reason? The reason is, if you have a weak acid and strong base titration, the equivalence point is on higher than 7. And if you're doing a strong acid and strong base titration, the equivalence point is around 7. Although this 7 is not in this range of 8.2 to 10, but still the phenolphthalein works out fine for the strong acid base titration, because you see a big jump from, if you look here, at let's say the pH is around 5, you add just 1 drop of the base and it changes, it makes a big change in the pH. So here So with phenolphthalein as the indicator, the pH range of the color change does not overlap the equivalence of at pH equals to 7. Now, so the main point here is that we just cannot use any indicator for any type of titration. We have to be very specific what indicator to use. The goal is that it changes color within the most vertical portion of the titration curve. Again, the indicator should change the color with this range, this vertical proportion of the titration curve. So therefore, we're going to use the appropriate indicator. So these are the pH ranges of selected indicator color changes. For example, if you look at the phenolphthalein, in the acidic medium it is colorless, but if the pH is between 8.2 to 10, the color changes to pink. Another very important indicator that we use is the 4.8, this one methyl red. It's red in color, but then it changes to yellow in this pH range. So you do not have to memorize these indicators. The list of these indicators along with their pH range and color change will be given to you, but you can have a question in the test, like example 17.14, and the simulated lab attached with this week work will also help you to understand the role of these indicators better. So the question is, select an appropriate indicator from table 17.1. This is table 17.1 for the titration of the weak acid with a strong base. So now weak acid, so the important thing is we are talking about weak acid and strong base. So the ideal indicator would change color within plus minus 1 unit of the equivalence point. Equivalence point, pH of 9.3. So that means any indicator like that shows the change in color from plus minus 1, 8.3 to 10.3 will work. Now, if you will going to look at the list, you will see, okay, phenolphthalein should work because it shows the color change any between 8.2 to 10. But since you're starting with an acid and adding the base, the pH will start low and increase, approaching this range from the lower end. So the lower bound of the phenolphthalein range is 8.2, which is just outside of the target endpoint range. So the best is here, if we look at this one, alizarin yellow, the lower bound is 10.1, which is within the target endpoint range. So this is the best choice.